Oops. Okay. How's everyone doing? Good? Yeah. This is the last talk of the day. You all excited? Are you excited? Okay, that's nice. That's nice. Um, I'm Menahi Shayan. I'm part of the engineering team at ZenDuty, which is an end-to-end incident management platform. So we basically deal into the SRE and DevOps side of things, alerting and those kind of things. I'm part of the engineering team over there. And I am going to be talking about building production-grade monorepos for React and React Native. So some of you might be familiar with these concepts, but they are new to many. So this talk is going to be a little different. For one, it's going to be relatively abstract. I'm not going to dive too deep into me writing code. You're not going to watch me write code. But this will also be a bit advanced because I'm going to be diving deep into bundlers and configurations within bundlers and things like that. So hold your horses. So it is obvious that JS today has evolved significantly beyond what was originally intended for. It has gone way beyond just building browser apps and into writing native React mobile and desktop apps. You can even build Windows and Mac apps for just using React. You can even build AR apps, VR apps, a lot of that stuff that React is now able to do. So how many of you have actually worked with React and React Native? Yeah. Oh, yeah, that's nice. That's nice. Okay. How many of you have tried building the same project, the same app in both React and in React Native? Yeah. Anyone? Okay. Okay. Yeah. So if you ever tried to build the same app in both React and React Native, right, you will maybe come into questions about how to structure these. What is the best way to actually share this code? What is the most optimized and most efficient way to actually share your code between React and React Native, or actually having the most efficient build process for these kind of things, right? The code base, if you will. How would one structure things like this? So a question like this will definitely not come up to you when you're building just a hobby project or just testing things out, but or even for a small actual, like, you know, a startup or things like that. But this problem comes in when you actually scale your code base, maybe like 3 to 5 years down the line, when your code base is growing exponentially, when you have thousands and thousands of files, when you have close to 1 million lines of code. How do you share this in the right way? And why do you want to do this? Someone would ask me, why would anyone want to listen to someone talking about how to structure a folder? Just do it however you want and move on with it, right? No, because this is very important. Structuring your code base, your large code base, the right way, especially in a commercial setting, actually directly determines how fast developers can make changes, how fast new developers can be onboarded, how fast you can fix bugs and push your bug fixes to production, right? They directly contribute to scalability and the productivity of the developer experience and your product itself, right? And going forward, people want to do this, right? So everyone involved actually wants shared code bases, shared applications built from the same platform that use the same code. Developers want to use the same code to build for multiple platforms. You want your app on web, you want your app on mobile, you want your app everywhere. Customers like using share common code, things that familiar experiences on both web and native. You can't have completely different experiences, right? And companies also want to do this. This is faster, this is easier to manage. So everyone involved wants to do this. How do you do this? So there are a lot of traditional approaches, a lot of ideas that have been thrown around online on Medium, on towards data science, maybe not that one, but a lot of these blogs that that are discussing how do you structure these. So we've looked into this. We have tried some of these approaches. Let's discuss these. First, different suffixes in the same folder. Let's say you have components that are being used in both web and native. And a lot of people actually have suggested online that you just have a dot Android or a React Native and a dot React in the same folder. So um, while that may get the job done, but this is really not scalable in large code bases. Let's say you have thousands and thousands of files, your tree is going to look like clutter. Another approach we saw is having entirely different folders. At this point, you should just like separate them entirely because there is no code sharing going on here. You cannot share anything. You just have two projects in the same folder. Now, let's say someone added, you have something common that you want to share. Let's say your massive API, right? You would have to copy the same code in both your projects. That's fine. I'll do that once. Okay, I'm done with it. A new guy comes in and makes a small code change, only to one of them. What are you going to do now? Do I have to sit and copy the entire code change into the other file that is being shared? Doesn't make sense, right? It's just not scalable to maintain two copies of the same thing. So yeah, another approach that we've seen is conditional imports. So people would say just in your main component, just make an index and just selectively import your web component or selectively import your native component. And every line you will just be doing if this, if that, else this, if that, if this, else that. It's just your folder structure is very clean. I'll give them that. But you open the actual file itself and it's just if else, if else, if else, if else. So that doesn't work either. Another one is Git submodules. Okay, this is we're delving into some complex territory here. So Git submodules are good, but they are increasingly difficult to maintain. For one, when you open your IDE's Git section, you will see 4 or 5 different Git repositories that you're connected to. Where do you push? Which branch do you check out? Let's say you're working with large teams, all right, and a different team has made, some file in a different submodule. How do you, which file do you check out? What if your branch is incompatible with that? Or what if their change is partially compatible with some of your submodules and not with your other submodules? It is just a whole mess of which branch to check out, which not to check out, where to commit, where not to commit, what is partially compatible, what is partially incompatible. So managing that can be a hassle. Some large teams have been able to successfully do it, but you would need like strict practices to actually pull off a submodule architecture well. So if not all of these, what worked? What is that one approach that worked perfectly for us in terms of scalability and ease of maintenance? Introducing Yarn workspaces. Yarn workspaces worked perfectly for us because for one, it was a single Git repo where we managed all of our projects. Right, we didn't have multiple Git repos or anything of that, but you could actually maintain multiple projects within the same repo. We would define our common, let's say API layer or our hooks package, and we would define them as third-party packages themselves. And we could just directly import them as, let's say Zen/API or Zen/hooks. They would be imported as if they were third-party packages, but they were defined right there as individual packages. We were able to share code without duplicates. So like I said, you can define a packages folder where you have all of your shared packages and you can just import them like you want inside your applications. It has dependency deduplication. What does that mean? Let's say you're sharing this, you're using a third-party package in multiple projects in both your web app and your React Native app. So what Yarn workspaces will do for you is it will not install the same package twice. It will actually deduplicate all of your dependencies. So that's really good. And there are a lot of additional benefits as well that we got from this. So that was great. So now here's the question. How do you move to a monorepo? It's quite simple, actually. You just get started with your initialized workspace setup and you define the packages that you want. Let's say your API and your hooks. You just define it there, name it however you want. And in your application, your actual React app and your React Native app, you just indicate them as dependencies. That's literally all it is. You're good to go. But yeah. Yeah, so how does that avoid the traditional approaches? So this is because we can, like I showed you the structure right there, you can actually define packages, right? You have things like applications, that is your actual React and React Native production apps. And you have packages. Packages are basically things that you share. Let's say your API layer, your hooks layer, right? Like I just said, you do not have to write them twice, right? So that solves that problem. They're only written once and they are shared, right? And you don't have to maintain multiple submodules because they're in the same Git repo. Things like that. And you do not have to have suffixes, separate suffixes for web and native, because they live as the part that is different lives as separate apps, right? So it actually avoids all of that problems. Yeah. Okay. Production grade challenges. So as someone interestingly caught on, it is not all roses, right? You cannot just run the 3 or 4 commands that I mentioned right here and be good to go. There will obviously be some challenges that you might face while moving a large code base to a Yarn monorepo, and we did face this. So what are some of the challenges that we faced? Well, for one, so a lot of this is legacy code, okay? Don't look at me and say, why did you write something this bad? This is all legacy code that we were moving to a production grade monorepo. So ensuring shared code compatibility. So let's say you've moved all of your hooks into a package, right? Let's say zen/hooks, and you're importing them in both React and React Native. The same file is being imported in both places. Now, you might come across some 5-year-old line that says window.location.href. So this is, do you see the problem with this? This will clearly not work in React Native, right? And things like this, you will find a lot of incompatible code. What do you do about code like this? So the simplest approach, right? So if things like these are few and far between, and they usually will be, you will not find too much incompatible code. So things like this can easily, you can just like move them out of the way with some conditional logic just for the part that is incompatible, or just substitute that with whatever is compatible on React Native, right? Just for few and far between things like this, you can actually use conditional logic to just get it out of the way. Handling deeply entangled code. So this is another problem that we faced. So let's say you have a file, just to display a toast message, for example, right? And this file is used everywhere. So if you were to search for this, you would find maybe 500, 600 occurrences of this file. So if you were to change the signature of this, you cannot actually, it's not practical, it's not feasible to make a big code change like what I just suggested. And what is this file doing? This file is basically, it's calling both React Toast and React Native Toast, and it's just conditionally exporting them. This is a problem, but a lot of people don't realize that this is a problem. How many of you think that this will work perfectly fine in both React and React Native? Are you wiping, adjusting your hair or raising your hand? Okay, never mind. Okay. Yeah, this will not work. This will crash. Why will this crash? Let's find out. So you saw there that someone is referencing React Native Toast over there, right? I mean, that's fine. We wrote this component. We know what it does. That's fine. That should work. But no, React Native Toast is likely calling React Native to actually render its views and components and all of that. But what is React Native calling? What is React Native importing? Let's find out. React Native is importing a lot of stuff. Things like CLI platform, Android, Gradle plugins and all this. How will any of this work in web? I mean, unless you're using React Native Web, which is a completely different thing. But how will any of this work in your browser? This will not. Right. So this is why your compiler will just crash the moment you run this. And you cannot do anything about this. You cannot actually change the file. You cannot change the way things are being exported because you will have to make changes in more than 500, 600 places. So what do you do when you just cannot make a code change? Simple. You just exclude what doesn't work. You go to your bundler, whatever it may be. It can be Webpack, it can be Rollup, it can be Vite, whatever it is, and just exclude the package that does not work. It's as simple as that. So what will happen the next time you run this is when it actually compiles this file, it will stop at the excluded dependency. So as long as you are sure that you are not referencing React Native, you're not explicitly calling the React Native code or initializing the React Native part, it will not have any issues running on your web browser. Simple as that. Sharing linter and formatter configs. So it is a DevX dream to actually have a standard ESLint config or a standard prettier config or a TS config across all of your projects, all of your mini apps that you use, everything, right? So for those of you who have worked on like large production projects, you would have noticed this, right? How many of you actually have worked with your ESLint configs and prettier configs and all of that? Yeah. So it just irks you when some things are not standard as per the config that you've so painstakingly defined. So when you're dealing with a large monorepo with like, let's say 5, 6 projects and like maybe 7, 8 shared packages and things like that, how do you ensure the consistency? How do you make sure that all of your projects are sticking to your standard ESLint and prettier config without, of course, defining it over and over again, because that is too much work. Yes, we like being lazy with these things. We will spend 4 hours on like creating a script to do it, but we will not just copy paste the file, right? So what is the most perfect way, most scalable way to do this? Extensions. It's as simple as that. You can just simply define it in one place. Let's say create a package out of it. Let's say zen/ESLint config, right? Define your shared, your standard ESLint config and prettier config and TS config and all of that stuff, and just extend it in every single project and application that you're using. It's as simple as that. Any single code change that you make to your config will instantly trickle down to everything that you're making. Handling partly scoped, partly shared dependencies. This is rare. This is relatively rare, but it was big enough that it became a very big issue. So, and it was from a major third-party package that we were using. We were using Sentry here. How many of you have heard of Sentry? Yeah, a lot of you have heard of Sentry. So Sentry does this scoped module thing where they have a CLI package and a React package and a React Native package and all of that. But this actually really did not work. This created such a big issue for us while we were moving to a monorepo. Why was this? Because we had a React Native application that was a front-facing application, the main React Native application that is, and we had a package called React Native Components, right? These two are separate in their directory structure. That was in packages, that was in apps. So obviously your Yarn workspace will only install one instance, right? It is deduplicated. So that was at the top level. It was at the parent node modules. Why was this a problem? We actually delved into the files that React Native, Sentry/React Native was addressing and things like that. And what do you know? They are hard coding the node modules path. Okay, and there is no way to override it. And if you look into their pod files and their Gradle files, there is no way to override the hard-coded React Native path that they have. So this was looking for CLI. It was trying to import a shared package. It was not working. Half of the Sentry scope dependencies were shared. Half of them were not shared. So they were in different node modules folders, right? And there was no way to scalably override them. I could make the code change once, but what if someone else runs a yarn install? What's going to happen then? I have to go there and make the code change for everyone, write a script for it. No, that just does not work. So this became such a big issue because even React Native had no way to override it. Sentry had no way to override it. We were not able to have duplicate packages. That was again creating an issue because it was already initialized. It was an issue to a point where we were planning to actually abandon Yarn monorepos and actually go to one of the older solutions. And then, you know how we solved it? The solution is laughable. Does anyone have an interesting idea to solve this problem? It's laughable. It is. We symlinked. We just created a link. We could not believe the facepalm, the reaction that we had when this was all it took to solve the problem. We did not have to create multiple dependencies. We did not have to duplicate our packages. We didn't have to do any code change. We didn't have to patch node modules or anything like that. We just created a link and it worked perfectly fine. It was able to find the parent CLI package that it wanted. It was able to build perfectly fine. Everything worked. And even maybe install it, put it to your post install. That's all it took. This was one of the most it was one of the hardest problems that we had to solve, but the solution was just so ridiculous, honestly. But that's how we solved a big problem that we had. Now, for those who are keen-eyed on this, who have actually worked deeply into React Native, right? You might notice that symlinks actually do not work in React Native. Symlinks, this will not work out of the box because React Native does not, Metro bundle does not have default support for symlinks. And that is where Microsoft came to the rescue. I know, right? So Microsoft had this extension for Metro that was able to resolve symlinks. And that is how we were able to successfully achieve this solution. Okay. The last challenge that we faced was having TypeScript and JavaScript projects in the same repo. How many of you have worked with TypeScript? That's a lot. Okay, that is more than what I've seen in a lot of other meetups that I've gone to. But okay, interesting. How many of you would love for all of your code to be written in TypeScript? Okay, okay, nice. Some of them are still like, I don't want to do the work. I don't want to write types. But yes, from a scalability point of view and like catching as many errors as you can at compile time rather than in runtime, right? Rather than have your customers come to you with saying this is not working, you would catch it in compile time itself. So TypeScript is really great, and it would be really great to actually have as much TypeScript as possible, right? There's no such thing as too much TypeScript. Maybe there is, but fine. How would you do this? How would you have TypeScript and JavaScript in the same project? So before we actually address the elephant in the room, let's address the bundlers and linters and formatters thing out of the way. So like I said, you can define a shared ESLint config, right, and inherit it everywhere. But what do you do for TypeScript? You want as much consistency as possible with your ESLint config and your TypeScript config, ideally, right? Should be as similar as possible and just build upon it. So what you can actually do is you can inherit your entire ESLint config inside your TS config. So a lot of people do not know that this is possible. You just inherit that and you just build upon that. So that made it really easy to have standardized configs in ESLint and TypeScript. But now let's address the elephant in the room. One of your apps are purely JavaScript. One of your apps are purely TypeScript. But they share a common package. What do you do? What language should your common package be written in? Should it be in TypeScript? JavaScript? How many of you would like to have it in TypeScript? Okay, how many of you would settle for JavaScript? No, so you would just not write it. Okay, nice. But unfortunately, this would have to be in JavaScript. Yeah, big groan to everyone who is an avid TypeScript fan here. You would have to do that in JavaScript because your JS compiler, that is your bundler, your Webpack bundler down there, will simply not be able to compile your TypeScript unless you have explicitly enabled TypeScript, right? And there were reasons why we were not able to do that. So unfortunately, it would have to be in JavaScript. But this solves the problem here. But over there, you're sort of losing a lot of the experience, right? You're losing the point of TypeScript if you have it, your shared packages in JavaScript. Can we make this better? There is something called JS docs. How many of you have heard of JS docs? Oh, okay, a few people. So JS docs basically allow you to write types like this. But what a lot of people do not know is you can actually write d.ts files and use TypeScript files inside JS docs. Even though this is a JavaScript file, there is no TypeScript in this file. I am actually writing the type definition through a TypeScript file. There is a d.ts file up there, and I'm just plainly importing that. I'm importing TypeScript inside JavaScript without any issues. And I'm getting all of the IDE, IntelliSense, and type checking and all of that. This is insane. How many of you knew that this was possible? This is like insane, right? Like a lot of people do not know that this is possible. Just add a TS check on top of that, and you're golden in terms of IDE level type checking. right? You have the IntelliSense, you have the type checking, you have a lot of stuff. But while we were implementing the solution, we came across something even better. This is a pro tip that I'm about to share to you. What happened? So let's take a step back and maybe think about what we just did. We have type definitions in TS syntax. We have TypeScript files that we're able to define our types and all of that. We have TS-based IntelliSense. Our IDE is giving us all of the IntelliSense and all of that through JS docs. And we have type checking within files. We basically have TypeScript. We have TypeScript without actually installing TypeScript here. So just maybe throw in some pre-commit hooks that do the validation beforehand, and you will not even be able to commit your files if there are type errors. Right? You basically have all of the type checking at the IDE level. Now, here's the thing. We thought about this for a moment and realized that IDE level type support that we achieved here was actually better than moving to TypeScript for us. This is hard to believe. A lot of people will come to me and say, no, that's not possible. You're just, that makes no sense. But why was this better for us? Through IDE level type support, right? We actually tried moving our code base to TypeScript, our React app that was in JS, right? We tried moving that to TypeScript, and then we just rolled back. But we rather later implemented IDE level type support. And turns out we had 2x faster compile time than actually implementing TypeScript at the bundler level. Rather than having your bundler and compiler do the type checking, doing it at the IDE level was twice as fast on our CI server. We were able to ship build faster, and we had a 4x lesser reduction in using build in our build resources. It used 4x lesser memory on our server. So that was faster and more efficient. And we were getting all of the benefits at the IDE level. So we found that this was actually better than and far faster and way more efficient than moving our code base to TypeScript. So that was great for us. Anyway, coming back. So those are just some of the benefits and some of the challenges that you would find while working with Yarn Monorepos. And this is just some of the reasons why it has worked perfectly for us, and it was the best solution out there that we could find. But it's not all roses, right? There may be some cases where you may want to take it with a grain of salt, where you may not want to use Yarn Monorepos. Complex ownership structures. Let's say, I was actually, yeah. So let's say you have some part of your code base that is shared, right? Let's say I want to make my API or my hooks open source. I want to make an SDK that is open source, and but the rest of my actual product is not open source. How would you handle that in a monorepo? Right? You can't partially open source a single repository. So complex ownership structures may not be the best thing. Minimal overlap. Files where projects where they're not sharing much. Cases where it's easier to move to React Native Web. So there is this thing called React Native Web where React Native can actually build for your browser as well. So if you're at the stage where you can convert your entire code base to RN Web, then go for it. Volatile and unrestricted merge policies where there is no branch protection or anything of that sort, where anyone can just merge volatile and breaking code and just break whatever is on main, right? If you do not have like strict branch protection set up, then maybe monorepos may not be the best solution for you. So what's the final verdict on this? Are monorepos right for you? I mean, you can't just do it because I've said it, right? You have to evaluate your code base. It definitely depends on a case-by-case basis. And you have to evaluate your code base based on what I just shared with you, and then decide whether monorepos are the best approach for you. But if your code base is anything like what I just described, or if you have experienced any of the issues that I just described here, then monorepos may be the best solution for you. Thank you.